All right, guys, this is going to be our second video on G&M codes. And so we're going to continue on. Last time we were looking at just kind of the history and kind of just basics of G&M code. What we're going to look at today are what some of those codes are. And so we do have these preparatory codes. These are the ones that are the G in the G code. And so there's a big list of them, and we're just going to go through some of them. There's obviously a lot more than what we have here. So we're just going to hit the highlights. And the first one I want to look at is G90. G90 is an absolute coordinates code. That just means that when we put in our coordinates for X, Y, and Z coordinates, that we are using an absolute coordinate system, meaning that every spot that we put in there has a specific location within our workspace. So it is not going to vary. 0, 0 is always going to be a 0, 0 on our work coordinate space that we're working on. And so we're going to start from whatever 0 is, and whatever coordinate you put is going to be referenced from 0, 0, and it will never vary. And then we have G91. So one of these two codes has to be at the beginning of every program you write. So G90 and G91 are both going to be used. It kind of just depends on what you're doing. Generally, we'll start with G90 for pretty much every program, and then you might switch to G91 for later ones. Relative coordinates are kind of like we did with the RoboCell, where relative coordinates is going to be relative to your current position, not relative to the 0, 0 point. So if I'm doing absolute coordinates, it's just like a Cartesian coordinate system. Every spot has a XY relative to 0, 0. With relative, it's just saying, how far am I going to move from where I am now? And so you may just be moving up or down or left or right from your current location, but you're not necessarily referencing back to 0, 0. All right, so other codes that you have, these are movement codes. We have one that's G00. That is a rapid traverse. That is basically what you're going to use when you want to move the spindle head around, but you're not actually going to cut anything. You just want to get it in position. And so this is a very useful command because it goes a lot faster. That's why it's not cutting, because you're moving at a speed that's way too fast to cut with. But it does get you around the mill a little bit quicker. So if you want to move from point A to point B just to get ready to start your next cut, this is the one we want to use. But again, we can only use it for non-cutting things. So if you're going to touch the part at all, you do not want to use this one. Straight line interpolation, that is the one that you're actually going to use to cut. So this one, we will have to set the feed rate when we do this. Otherwise, it will use whatever the last feed rate we had in there. We'll talk about that a little bit more later. But G01 is how you do a straight line cut. And then G02 and G03 are going to be arcs. So if we want to cut an arc, these are the ones we have now. If you look, it says circular interpolation, and that is important because when we use this, it has to be a circle. And that causes some problems in some cases. At the very least, it may cause some of your code to be really long, because if I want to do any sort of an arc, I'm going to have to put it together either as a bunch of little pieces of a circle to approximate some arc that is not circular, or I have to make sure that my cuts are circular. And you'll see that in a lot of parts. A lot of parts will have circles as opposed to other shapes that they could have. Not necessarily for this reason, but it definitely makes your G code easier if you use circles. So when you're using this command later, we'll talk about how to use these. You will have to make sure that you're using a true circle when you start putting in your coordinates. And then the 02 is going to be a clockwise turn. And then 03 is counterclockwise, and that is also important as far as which way you want it to go, as to how it's going to cut. So you got to think through kind of which way are you going to go, clockwise or counterclockwise. All right, so then there's some other codes we won't use very often, and I'll go ahead and click through. Oops, let me go back. These two, dwell and pause, we don't really use those very often directly. I mean, we don't use them. They will get used occasionally in code that's computer generated code that we might run into. Dwell is just really going to be just wait for something to happen. Usually dwell gets used more for operations where you might have something else happening. So if I'm doing something where I have coolant that's going to be sprayed, and maybe it dwells and waits for me to spray some coolant on before I go to the next step, or maybe I need to let something else happen. I don't know what else would be going on in your code, but It's not one we use because we don't really have any need for that, but it is something that they might have in code. Again, specifically for things like coolant or something like that. Same thing for pause. You might put a pause in there because you're going to need to go in and do something. We don't ever really do that because we're going to do a tool change or something like that. We will use a tool change command and that will take care of that. But if you have some individual step that you need to do where, between this step and that step, I needed to wait for something to happen, you can put a pause in there. All right, so we talked about arcs a minute ago. This is how arcs work. So when we have an arc, we're going to have our initial position, we have a final position, and we have a center point that we're going to work around. And so when we are putting in our coordinates, what we need to do is we need to identify where we want to go to and what center point are we rotating around. What is our center of our arc that we're working with? And again, these are always circular arcs. So this first position, the X1, Y2, that position you'll already be at. This one is not going to go into your command line. You should already have gotten to that point with your previous command lines, your previous steps. And so in our command line, when we're actually putting this code in there, we are going to use our G02 code to go from that starting position. So if you notice here in this little bit of code example they gave you, they had it go to this position first. So we did a linear interpolation. So we cut from wherever we were to this point, but we're now at X1, Y2. That is our location. We are going to go from there with our clockwise rotation, clockwise arc, from this point that we're at to this point. So we're identifying the end of the arc in our command. And then over here, this I and J. I and J are what we use for the center point. So we use X and Y for the actual coordinate point we're going to. I and J are reference points that we are using to reference where our center is. I is like the X coordinate, J is the Y coordinate of that center point. And so that's what this point represents. So this is going to be a method for doing that with our absolute coordinates that we use the actual coordinates. We're using X2, Y1, and then I1, J1 to put into our command. The other thing we can do is relative coordinates. And again, relative coordinates, we are not referring to where we are on the XY coordinate grid. We are just referring to how far am I going from where I currently am. So again, here I am going to get to this initial starting point somehow or another. And so in this case, I'm in this relative command. So I relatively somehow have gotten to this position. This is where I'm at. What I need to do my arc then is I need to say how far from where I am now do I need to go to get to my final position. So in this case, I need to go over 1 and down 1. So I'm going my X1, Y1, -1. Y is -1 because we're going down 1 unit. So over 1, down 1. And then same thing with our center point. When we do relative coordinates, it's relative to where our starting position is. So our starting position is right here above it. We don't need to move at all in the X direction. So our X is 0 and our J, we have to come down 1 to get to that center point. So our center point is 1 down. So it's -1 from my starting point. That is how I get to that point. So when I do absolute, I'm looking at the actual coordinates. So this is 0, 0. This is at 1, 2. This is at 2, 1. And so I'm putting in those coordinates to say, I'm going from here to here. For this one, I'm saying to get from this point to this point, this is not the actual XY coordinate on my Cartesian coordinate system. This is not 2, 1. This is how far do I have to go from here to get to that final position. So I'm going over 1 and down 1. That is what I put in when I use relative. Okay. The second method with arcs that you can use, and it works okay, but you have to be a little bit careful about, clockwise and counterclockwise and making sure everything works correctly, is that instead of using a center point, I can use an arc, basically the radius, to define what the arc is. So if I want to say, here's where I'm starting, here's where I'm ending, and I want the radius to be this much, you can go that route, but you have to be a little bit careful that you are thinking through where that center point probably would be so that you get the arc to work out correctly, but you don't ever actually have to put in the center point for that. So this method, you would still put your final coordinates. So if I'm going from this position at 1, 2 down here to 2, 1, I still need to put that 2, 1 in for my final position. but then my radius would be 1. And that's because I'm looking over here and I say, okay, well, the radius of this arc, this circle that I'm making, is a circle with a radius of 1. If I made that 2, then my center point would have been down here at 0, 0, and my arc would have been different. It would still be circular, but I would just be getting not a quarter circle anymore. I'm going to get a different amount of that circumference. So you can play with that radius a little bit. If you don't want to have to figure out what the actual center point is, you can use a radius, but you do have to pay attention to whether you put it as a clockwise or counterclockwise arc. If I put clockwise arc, it's going to rotate this way. If I did counterclockwise, it'd actually come down and then go around this way. So I'm going to get a kind of a arc that goes down instead of down first and then to the right instead of to the right and down. For relative, same thing. I just put my final relative coordinate in terms of where I need to go from where I am now. So over 1 and down 1. And then I can put my radius as 1. That won't change. The radius part will stay the same. But again, you have to be a little bit careful. Sometimes it interprets things a little differently than the way you're thinking about it. So you just have to make sure that you're clear on how you're doing that. Okay, some other G codes that you'll run into. We'll talk about all these. I'm just going to click them all up here on the screen real quick. So we have G20. That is just basically units are we using. So are you putting everything in inches or are you putting everything into millimeters? If I use inch, I want G20 in there. That's, again, a beginning of the code type of thing that I'm going to put early in my program to kind of specify what I'm using before I start actually referring to coordinates. And then G21 says we're going to be in millimeters. Those are really the only options that we have. There may be a G code for other units besides those, but realistically, millimeters and inches are what we're going to use. The rest of these we will not get into. These are a little more complex things where you're doing cycles. A cycle just means it's multiple steps. So you can kind of create these cycles and have it go through and do all these steps in one. So it's almost like a function or subprogram. But we're not going to get into. Honestly, I don't even know how to create them. But we're not going to get into that. But it is something that you can reference and use if you have something that's going to happen over and over again. So you might have like a really repetitive, drilling process or something like that. You might use some of these on. All right, other codes we have. These are the M codes. These are miscellaneous codes. And I'm just going to, again, click them all up here on the screen so you can kind of see them, and we'll talk about them real quick. So M0 is pause. Again, we don't really use that one hardly ever. You could put it in there, but we really don't use that one. M01 is optional stop. We're also not going to use that one either. So the ones that we are going to use are these ones that are in black. So end of program. When you get to the end of your code, this is how it knows that you're done. It's like putting the end bracket on your robot C programming. You want to put in M02 to say, yes, I have reached the end of my program. And that is how it knows that it's done. M03 turns the spindle on, so that's going to turn on the tool head, so it's going to start spinning it so that you can actually cut something. If you have not turned that on, we're going to have problems when you go down and try to cut, so you want to make sure you do that. M05 turns the spindle off. We'll use that towards the end of the code, or if you're just going to be moving and you just don't want the spindle spinning while you're moving things around, you can use that then as well. And then the other one that we're going to use quite a bit is M06, which is our tool change. Anytime we want to change from one tool to another, we're going to use that command. The way our mill works is that it will move to a tool change position, which is going to be up above the part. It moves to like a safe position to where you can change out the tools and you put the new tool in, and then you can resume the program after that. The rest of these are things, again, we won't really use, but can be used. So you have the accessory on, and you have two different accessory options on and off for both of those. So if you have light, or if you have some sort of a cooling system, maybe you got some cooling fluids you're going to put on there, some sort of lubricant, something like that. This would be how you turn those things on and off. Or maybe you have a vacuum system you want to turn on and off to vacuum up some of the chip. Whatever it is, this is how you can control those. If you have them, we don't have them, so we're not going to use that, but you could. If you want to end your program and start it over, so if you're doing something like this kind of goes with this rewind here. We talked about handshaking, where you're running like a robot arm working with the mill. This might be the command you'd use to say, okay, I've finished this one now. I've finished this program. I'm going to reset back to the beginning, or I'm going to rewind back to a previous step to redo whatever that thing was. So maybe I'm milling that same part over and over again, or whatever it is. All right, some suggestions, and this is going to be the last part we talk about, is some code suggestions. We don't necessarily have to repeat every bit of code every single time. If we're not making a change, a lot of the stuff that we have is going to just stay the same, and that's what they call modal programming. So, for example, if I am not changing the height, if I'm cutting through material and my Z position, my Z height of my cutting tool doesn't change, I don't have to continually put that in there. I can just leave it blank, and it will hold the last value that we had. Now, sometimes it's good, sometimes it's bad, but that would be what they consider modal programming. So if you're not changing something, if you leave it blank, it will hold the last value for most of the things we do. Feed rates will be that way. Spindle speeds will be that way. We don't have to continually define those over and over again every time we run a new step. Those things are held in memory and remember what that was from before. And so when you're doing your programming and you're doing coordinates, if you're moving vertically or you're moving horizontally, I may not need to put the X coordinate, or I may not need to put the Y coordinate if I'm not changing those. I would say for right now, it's probably safer to go ahead and put all those coordinates in, even if you're not changing them, just so you don't forget something by accident. But you can definitely shorten up code, and that's what you're going to see when you get the computer generated code, that's what they're going to use. One of the things that they also just recommend, just put a little bit of space between your comments and your code, just so you can kind of see the difference between your code and your comments. So that's what they're saying here, to have those remarks over. The main thing that we definitely need to do, you definitely want to put absolute relative coordinate system, that code in at the beginning. And then also, are you doing intrametric? We'll usually put those all in the same line of code, just kind of like a single line of just specifying all these things. What type of coordinate system we're using, what units are we using. Then we always want to use tool change to change tools. You don't want to just manually move the tool up and stop the spindle or anything like that, because then you're going to have to put in a whole lot of extra code, and you're going to have to put in pauses and things like that. When we do tool change, just use the tool change command. It will automatically move the mill up to a safe position for you to change, and then pause and wait for you to change the mill out. And then you definitely want to put in your spindle speed every time you turn on the spindle, unless when you start your program, because you don't want it to remember what it used last time, because what it used last time, that modal memory that it has, maybe you're using something completely different, and if you don't indicate what it needs to be, it's going to forget and give you maybe a speed that's too fast or too slow, and so you want to make sure you're putting that in. Same thing for speed rate, the feed rate of it. You want to put the feed rate in every time you change what you're doing. Okay, almost to the end here. One of the things we definitely want to do is at the beginning and the end, we're going to want to basically make sure we know where we're starting and ending our mill position. And so at the beginning, we want to make sure we start by moving to our XY position first, and then we're going to move in Z. So we don't ever actually want to move in X, Y, and Z all at the same time. We want our motions to be either horizontal, where we stay in the horizontal plane, or vertical. So what we generally would like to do is move to our XY coordinate first, and then move down in the Z direction, so we come straight down as we're cutting. And the reason why, as we're talking about here, is prevents ramping or inverted cutting. If you're moving three-dimensionally, where you're moving X, Y, and Z all at the same time, it is very possible, in fact, pretty likely, that at some point you're going to accidentally clip an edge of something on your part that you didn't really mean to cut. And so to prevent that, we don't want to ever move all three axes at the same time if we can help it. And then the last thing, we definitely want to make sure when we get to the end of the program to make sure we don't leave the tool down in the material. You don't want to like stop it. I finished my cut, I'm just going to stop the code. I want to make sure I move up to a safe location, so that when it's ending the program, I can open it up and get there, and I don't have to like try to pull the bit out of my material. And so that's what we're talking about here. Always move to that safe unload position, turn the spindle off, make sure you kind of close out everything at the end of your code. And then we'll use our M2 code to end it. All right, that's the end of this video. Thank you very much for listening.